What the hell was that?
Hello and welcome back to the second part about enemies for our game. This one, as planned, will be about making the enemy patrol. And it needs to know about the level around itself to be able to patrol. So this will be fun to add. Before we get into the update, hit that subscribe button and also like the video if you enjoy this content. There's more fun stuff planned, you don't want to miss out. And as a reminder, all of the code and assets can be found on my website or on GitHub. If you have questions about this tutorial, or maybe you get stuck somewhere, check out the Discord link. And if you want to go the extra mile to show your support, there's a link below where you can buy me a coffee. Even though I don't drink coffee, I'm a tea guy. Now, let's do a quick recap about our current progress of the enemy. In the first part, we added our base code for our enemies to work. We made a new enemy class that will be the super class for all our enemies. Then of course, we added our first type of enemy, the crab. This was followed by adding the constant values for our enemies, just like we have for our player. Different states and also the enemy size, for example. With our enemy manager, we can keep all the code regarding the enemies in that class, making it much easier to read the code and also debug in case we get issues further down the road. By adding one more method in our load and save class, we could now use the green pixels in our level data file to place our enemies wherever we want them to spawn. Finally, we test our daily progress and voila! We now have our first enemy in the game. He's quite useless as of now, but with time and some code, he will be dangerous. Alright, let's begin. But not with the enemies, but with two fixes that we need to address. And the first fix is coming from Pretenshitray? Yeah, that's how you pronounce it, no questions asked. But anyways, we're gonna add our level offset to our hitbox. So that's the first fix. So it's pretty simple. We simply go to our entities and into our entity class where we have the hitbox. We simply ask for it, int x level offset. And we take that, pass it along to our x variable and minus x level offset. Simple as that. And if you're still drawing the hitbox, you should have an error in playing, I think. Yeah, so if you were drawing the hitbox, you would get an error here, but all we have to do is to level offset. Just pass it along the hitbox and we're good. And the second fix is from another Discord user called Blasty. And it has to do with whenever we start a game, our window is not centered. It just doesn't look completely correct. And the way we're gonna fix that is by going into our main package, go to our game window. And what we're going to do here is to take set location relative to and paste it after our .pack. So let's see the difference. And now it's in the center. Much better. So thank you, Blasty. Now let's begin with the actual episode. And we will start inside our Krabby class by just adding our hitbox. So init, hitbox, and this method we have since before. So all we need to do is to give it some values and then we have a hitbox. And the hitbox will have a x and y, that will be the same. But the width will actually be 22 and the height will be 19. And this is just the size of the hitbox that we actually want to be able to interact with the level and also objects or the player. So 22 by 19 is a good size. And we must not forget, we need to use game scale here. So int, recasting it over, and then times game.scale. Because it should increase in size if we increase the game scale. And the same goes for its height, so recast over to int and then times game.scale. And that's all we need to do for our hitbox for now. Now, with our hitbox added, whenever we draw the enemy and also check for collisions and the player later on, we're always going to use the hitbox X and Y. So if we were to draw the sprite of the enemy at those positions, it would look weird, it would be off. Because the size of the actual hitbox is much smaller than the actual sprite. So we need some sort of draw offsets, just like we have inside our player class. We could add them inside our Krabby class, but we are most likely going to have more crabs than just one. That means that we can go to our utils package and our constant class and add the constant values for our enemy DrawOffset in here as well. So right here inside our inner class, enemy constants, at the bottom of all our public set of final here, we add a public static final int Krabby DrawOffset x is equal to, and we're gonna cast it over to int because we need to use game.scale here as well. And it will be 26 for x times game.scale. And we might as well copy this entire line, paste it there, and change it to y. And then instead of 26, we're gonna have 9. And these two values, 26 and 9, is simply the difference between the start of the sprite to the start of the hitbox. And that's all for our draw offsets. And now we'll get to the bigger part of this update. And that is to add a UpdateMove method. So inside our enemy class, we're going to add a private void UpdateMove. And it is inside this method that we're gonna calculate and code out how the enemy is gonna, first of all, in this episode, be able to patrol and move around. And in the next update, it will be about how the enemy can see the player and therefore change behaviors. But we're gonna stick to this update, and right now we want the enemy to be able to patrol, and that's it. But first, if we take a look at the game and start it, our enemy is in the air. Well, he can't be there. So we're gonna add a fall mechanic just as a start. We will not allow the enemy to fall off edges, but we want the enemy to fall down to the floor if they are spawned in the air. And if we did add the fall mechanic to the enemy when he's running around, then that would be able to change the dynamic of how the enemy should behave actually in the game. So that's a choice you can make. I'm gonna code out the simplest version, and that's not to allow the player, or rather the enemy, to fall from edges. If you're a little bit more experienced, you could code that in, but that's completely up to you. But first, we are going to need some way of detecting the level in our enemy class. And that way we're gonna do that is to ask for int level data. And we could add the level data up here in our enemy class, but we are going to have more than just one enemy, so keeping this stored in each instance of our enemy, not the greatest move, so we're gonna just give it the level data for each update. And this update move will be inside our main update, and it should actually be before we check the animation tick. So before the animation tick we have the update move, but we need this level data in our main update as well, and then we simply pass that along to our update move. But now we get an error in our enemy manager, and that's because we have no access to level data here either. So I'm just gonna copy this variable, I'm gonna place it in our main update method here in enemy manager, save it, and now we have an error in our playing as well. And that's of course in our update method here as well. And the way we're gonna get the level data is simply to call our level manager, get current data, just like we do when we load the level data to our player. So we're just gonna copy this line, paste it in our update method here for enemy manager, back to enemy manager, and just making sure that we pass it along to each enemy. Like so. So now in our enemy class we have the level data. So the first line of code inside our update move will be if first update. We're gonna do something for the first time we ever update this method. And we're gonna add a boolean up here, private boolean first update. And it's going to be true by default, because when we start the game, it should be true. So first update. And fist update, no, first update, not fist update. All right, so if it's our first update, then we want to check if not is entity on floor, I think it was called. We need to import it from our help method. So import static utils dot help methods dot can, or rather is entity on floor. We might need more, but let's just grab that method. So is entity on floor, what is he asking for? The hitbox and the level data. Hitbox and the level data. If this returns, level data. If this returns false, meaning we are not on the floor, then we want to say in air equals true. And we can go up here and just add private boolean in air equals false. Or rather, we don't need to specify in air, we can just say in air. And we can actually remove these brackets because we're just checking if it's not on the floor, then we are in the air. Then, if we are in air, or rather in air, so this can happen not just the first update, but after the first update, we're checking if we are in the air, then we need to keep falling down. Else, we can add the actual main part of this code. But right now, we're just going to focus on this bracket right here. And just like the player, we add if can move here. We need to import that one as well. So instead of is entity on floor only, we grab all the methods. And then can move here. We need a hitbox.x, hitbox.y. What else? Width and height, and then level data. So box.width, and we need box.height, and then level data. Right now we're just checking the position, so this will always be true, but we need to add the fall speed, just like we have for our player, but we need one here as well. So private float fall speed. And if that's the case, then hitbox dot y plus equals fall speed. And then we say fall speed plus equals gravity. And we need to add gravity as well up here. Private float gravity is equal to 0.04 float times game.scale. So it's the same as the one in the playing class or in the player class. But at some point, this will return false. That means that we have now fallen enough that our next move would cause us to be inside the floor. So we need to say in air equals false. And then we say hitbox.y is equal to get entity y position on the roof or above floor. We pass in hitbox and the airspeed. This is the power of having methods that you can use over and over again from different angles, and they always work. All right, hold on a second. This is Karin from the future. And I just realized that throughout this entire update, we are using the animation speed instead of fall speed in our method right there. So it should be fall speed and not animation speed. It will still work, but we should probably use the correct variable here. So it should be fall speed and not animation speed in our get entity y position on the roof or above the floor. So just change that to fall speed and we're good. Now back to the present Karin or before Karin or however this works. I'm not sure, but back to the original recordings. And now we will add the patrolling part of this update. So first we had if it's in the air, then we do everything in here. But at some point the enemy is gonna fall to the floor and never be in air ever again. And that's when we enter this. And I just realized that we forgot one little itsy bitsy part, and that's in here. If it's the first update, then we're never going to go inside here ever again. So we need to add a bracket here around it, and then we call first update equals false. This way we don't enter here ever again. So that's the first part. And now we can add the patrolling part of our game. And right here we're going to add a switch, and we're going to check for enemy state, meaning different states we're going to do something different. And we're currently only going to test for 2 of them. We're going to test case for idle and then case running. And the reason why we're only checking for these 2 is because we only want to fix for the patrolling right now. We don't need attacking, dying, etc. So if it's in the idle, we're going to do something super simple by saying enemy state is equal running. There could be a case later where we have some other code in here, but for now, enemy starts in the idle and then it goes to running. And then we just add a break statement there. But if we are in the running, which we will be whenever we are patrolling, we're gonna have to do a few checks and add a few variables. And in the player, we have a float x speed equals 0. If we are walking direction is equal to left, then we x speed minus equal walk speed. And we need a few variables. The left, for example, we can import from our constant class. Import static utils dot constants dot directions. And we're gonna take all of them. So in case we are walking to the left, and then we need walking dir and walking speed up here. And it's going to be a private float, I think. Let's check the player and use him as a reference. So we have player speed is this one. So we're going to take that one. Float walk speed is equal to 1 float times game.scale. And private int walk there is equal to, well, let's go with left to begin with. So if we are walking to the left, x speed is minus equal walk speed, else x speed is plus equal walk speed. And since we are not dealing with both left and right at the same time, we might as well just say is equal to negative walk speed is equal to walk speed. It will have the same effect, but this looks a little bit better. And then with this x speed, we can check whether or not we can move to the left or to the right. So we need a old-fashioned can move here. We have hitbox.x. We have hitbox.y. Hitbox.width, hitbox.height, and level data. If that's the case, then, well, move here. But we're going to run into an issue. We never check whether or not it's an edge, meaning if we walk here, will we fall down at some point? And we don't want to make the enemy fall down, so we need to check another boolean here as well. So if is floor, and we will simply pass in the hitbox for its position. Then we will ask for the x speed and of course level data. And if this returns true, then we say hitbox.x plus equals x speed. And then we return. And I'm gonna get to why we are returning in a second. But first of all, we need to use the x speed for our position where we're testing as well. So we're testing this position plus x speed. If we can walk there, is it a floor, this position plus x speed? If that's the case, then we increase x with x speed and we return out of here. But we need this is floor. So we're gonna take that and we're gonna place it in our help methods class at the very bottom here. So public static boolean is floor. static. And we asked for a hitbox, which is a rectangle 2D.float hitbox. Then we ask for the speed, which is a float x speed, and of course the level data. And I'm gonna cheat and copy. And then we're gonna return whether or not this is true or false. And it's gonna be a simple line of code here. We can use is solid, so return is solid, the current position, which is hitbox.x plus x speed, hitbox.y, and the level data. And if it's a solid, then we can walk there. If it's not a solid, then we want to do something else. So we're gonna save this. We can close down help methods, go back to our enemy class, and at some point we're either gonna get this one a false, or this one will return false. And if that's the case, then we add simply a change walk dir right there. And we're only gonna get to this section right here if either this one returns false or this one returns false. If both of them are true, well, we have the return here, so we never enter this section here. So this will simply change from left to right and right to left. So let's create this method. And it's going to check if walk dir is equal to left, then walk dir equals right, else walk dir equals left. And we need another one like so. And it's left with big letters like so. And I think I've coded everything right. Why don't we give this a try and see how it looks? And now the enemy is just running in the place for some reason. Why is that? And that's a little miss from me. In our help methods, where we check whether or not the floor is true or false, we are not actually checking the floor. Hitbox.x is top left plus x speed is top left plus or minus the speed. And then hitbox.y, which is still top left, we need to say plus hitbox.height. So now we're at the bottom, and then we need to go +1 because we're not checking the bottom of our hitbox. We're actually checking the pixel below our hitbox. So this should work much better. Let's give it a try.
Fast as
and
fuck,
whoa,
boy.
he went away fast. Let's see him in action. So he's running, and then he gets to an edge and he runs back. And he keeps the same speed as the player. And he found the wall here, and he changed directions. So yeah, we have now a quite fast crab walking. I think we're going to have to slow him down a little bit. In our enemy class, walk speed, let's try half. Let's try half that. So yeah, that's better. Maybe even slightly slower, so 0.5 to 0.35. That might be a good speed, I don't know. Yeah, I think that's better. If you want to make it harder, maybe the enemy should run faster. But for now, we're gonna keep this speed at 0.35. Perfect. Alright, we released our enemy to the wild and now he's running around. It's a good progress for today. We will of course continue this in the next update. So make sure you subscribe, and if you enjoyed this video, hit the like button too. Until the next video, take care now and have a wonderful day. Bye.